All right, so right now I'm talking about the Chatelier principle. So I want to right now in this in this video, I want to talk about the catalyst inhibitor concentration and the solid or liquid in gas system. So if you have catalyst or inhibitor, the equilibrium will be no shift. Now inhibitor will decrease the rate, but it will decrease both the forward and the reverse rate at the same amount. So in general, the position of the equilibrium will not shift. And same thing for catalyst. Catalyst will increase the rate, but increase forward rate and the reverse rate at the same amount. So in general, the equilibrium will not shift. The speed of the reaction gets speed up, but the equilibrium would not shift. Equilibrium meaning like how much you do you produce more reactant or you produce more product. Okay, so here the speed will speed up, meaning like I will produce more product, I will produce the reactant faster, I will produce the product faster, but I would not produce more product, I would not produce more reactant. The equilibrium, no shift. And the reason you can just write catalyst present or inhibitor is present. And then if you notice that there's gas in the system, okay, even though you only have one gas, we will call that is a gas system. So if you're changing any solid or liquid in the gas system, okay, you change the concentration of the solid or gas system, you also no shift, because the concentration of the solid and liquid, they are 100% pure, so they have nothing to do with the gas system. So on the reason, you can just write whatever the compound is a solid and liquid in gas system. If it is not a gas system, the change of the solid and liquid, if it's not a gas system, the change of the solid and liquid will be talking about concentration change. Okay, so now concentration change, we have two situations. If you are already happy in the equilibrium and I suddenly increase the concentration, okay, you will try to do something against about what I just do on you. So for example, if I said that, let's say you are happy with your equilibrium, okay, you are happy with your system. Now I suddenly increase the concentration of your fat, okay, because you were already happy. So you don't want to stay with this. You want to stay away from the fat that I gave you. So you want to stay away from the concentration of that substance that I gave you. So if I suddenly increase the concentration, you will stay away from the systems because you want to throw away the extra thing. So the reason you can write, okay, because the concentration increase, I want to stay away from that substance. And on the other hand, if I am already at the equilibrium with the fat, okay, I am with this fat and I'm already equilibrium, you suddenly decrease my concentration, that means you suddenly take this away. What I want to do is I want to get it back. I want to get it back. So in this case, I will shift my equilibrium toward to the substance because I want to get it back. So then here the reason you can write, oh, because I lose my concentration, so I want to stay toward the concentration because I want to get back the stuff that I lost. So we got to talk about the concentration right now. And then we can go to the actually we can go to this notes. Okay, we can go to this one. Okay. So we have two things we want to talk about. Identify. First is if it is a gas system. So it is a gas system because I found a gas. And the second thing is talking about the energy thing. So this part will be discussed in the next video when we're talking about temperature. So, but again, at the beginning of the question, two things you want to identify. One is this a gas system? Because you have a gas, okay? So now here, let's look up number one, okay? You always want to start with the reason thing first, then you can determine the answer. So your N2 is increased, okay? So we want to write, okay, because my N2 concentration increased. So what do I want to do? I don't want it. I want to throw that away. So I want to stay away from the N2, okay? Because the N2 increased, it messed up my equilibrium. So my body tells me I want to stay away from it. I don't want it. So N2, if you look at this equilibrium sign, this is look like an equal sign. So N2 is on the left-hand side of the equilibrium. If I want to stay away from N2, that means I don't want to stay on the left-hand side because I want to stay away from the N2. That means I want to stay on the right-hand side. So my equilibrium will shift to the right. Because I want to shift to the right, it will go to the product because the right side is the product. Okay, now so let's look up number 3. NH3 is increased. So again, because NH3 concentration increased, so your body do not want to stay with it. You want to stay away from the NH3 because you want to lose the extra thing. You want to throw that away. So NH3 is on the right-hand side of the equal sign. The NH3 is on the right-hand side of the equal sign. So you want to stay away from NH3. That means you don't want to stay on the right-hand side. You want to stay on the left-hand side. So your equilibrium will shift to the left. Because you want to shift to the left, your favorite will be reactant. Okay? So let's look at number 5. N2 is decreased. Now, N2 decrease because just like the situation, like I'm already happy with this. Now you suddenly take away my N2, so that my N2 decrease. So you take away from it. So what do I want to do? I want to get it back. So I want to stay toward to the N2 because I want to get back the thing that I lost. If you decrease my concentration, I want to stay toward to N2 because I want to get it back. So here, my N2 is on the left-hand side of the equation. Since I want to stay toward to N2, I want to stay at the left-hand side because I want to stay toward the N2. So my equilibrium will shift to the left because I want to stay with the N2. So my equilibrium shifts to the left, so I will favor to the reactant because I want to go to the left-hand side. And then number 7, NH3 is decreased. So same idea. NH3 decreased, it go down, so I want to get it back. So I want to stay toward to NH3. Now NH3 is on the right-hand side of the equation. If I want to stay toward it, I want to stay on the right-hand side. I want to stay on the right-hand side, so my equilibrium will shift to the product. Okay. Now let's look at number 9. Number 9, a catalyst is added. So a catalyst in equilibrium would not do anything. So will be no shift, no favor. Catalyst is present. So this is page 1. Okay. Let me go to page 2. Okay. Now page 2 again basically is the same thing. You want to identify where there's a gas system. Okay, it's a gas system. And then number 2 is talking about temperature thing. So that would be another video. So the only thing I want to talk about is number 5. Now, this is a gas system, okay? But look at number 5, H2 is decreased. Now, in my equation, I don't have any H2. If I don't have any H2, would be no shift, no favor. Because H2 is not in the system, okay? If something that is not on the system, you add on it, you decrease on it, would not change the equilibrium. Because I don't have H2 on the equation. I don't have H2 on the system. Okay, so H3 is not on the system, so no shift, no favor. All right, now let's look up at the bottom. Again, this is the gas system. Even though I have solid, but as long as I have gas, I would say this is a gas system. Okay, and I want to talk about 2 things. Number 1 is this is a gas system, but CaCO3 I gave you is a solid. So it will go back to my table when we have solid or gas in a gas system and I change my solid or liquid, will be no shift. Okay, because whatever that I gave you is a solid or liquid in the gas system, so it will be no shift. So here, since CaCO3 is a solid in gas system, now you have to specify this is a gas system. Okay, because if you don't worry about gas system, you say CaCO3 is a solid. Well, if it's solid, I change the concentration, I should make shift. Okay, because if I change the concentration, I will make shift. But if you specify this is a gas system, okay, then no matter how much I add or how much I remove, will be no shift because it is a gas system, and the thing that I'm going to change is a solid. So you have to specify it's a gas system. Otherwise, you're talking about concentration. The last thing I want to talk about is the CO2. Now, CO2 is a gas. Now, in this case, if I increase the CO2 concentration, because it's a gas system, I can talk about the concentration now, because CO2 is a gas. So CO2 concentration increase, again, I want to stay away from CO2, because I want to lose it. So in this case, I want to stay away from CO2, so I don't want to stay on the right-hand side. I want to stay on the left-hand side of the system. So I will go to the left and I will favor my reactant. So that's the difference between number 1 and number 3. Number 1, if a solid in the gas system, won't change. If it's a gas, then regularly you're talking about concentration, which is the same thing as the front page.